everything is the same lengthwise on the side length. Yeah, and so usually they just label it with an S. This side is the same as that side, is the same as that side. They're all three equal in size. So what does that mean for volume and surface area? Well, the volume, you got your length, width, and your height is all S. S times S times S. Well, that's simply put S cubed. Volume of a cube is S cubed. And the surface area would work like this. We've got, back to again, the 6 surfaces. So let's, the front is a square, the side is the same size. Yeah, the front's, the area of it is S squared, and so is the side, and the top, the bottom, and the back. All of them are S squared, and you got 6 of them. So the surface area of a cube, 6S squared. All right? So that's how it works for a cube. All right? Now, again, ones I like to get you to think about, what if this cube had no top? If the cube had no top, then volume's still S cubed, but what about the surface area? Well, if there's no top, you only have 5 surfaces, so you only have 5S squareds, right? So anyway, let's move to let's go to the cylinder. Circular cylinder. All right. So a cylinder, got a circle in the body, and then you got the circular base. Okay, can shape is what we're talking about. All right, well, let me try to explain to you the volume. You need 2 things on a cylinder. You need to know 2 things. You need to know the radius of the circle, R, and then you need to know the height of the cylinder, top to bottom. You need to know those 2 things. Okay, let me try to explain the volume a little bit. Let me go back to the box here. If you think about a box, a box is, if you think of starting with a rectangle here, that's going to be the top, going back there. Then that rectangle, then I move it through, it's an L by W rectangle. If I then take that through your height of H, move it through a height of H, kind of a way you can think of constructing a box a little bit differently there. The reason I mention that is because the cylinder is similar in that you'd start with a circle and then move it through a height of H. Okay? So circle, move down through H. Okay. Why do I mention that? Well, think about this. The volume formula is LWH for the box, but think about this. What I started with was the rectangle, which is LW, area. And then I take it through height of H, so think of it that way. Think of this as the area of a rectangle, LW times H. That's one way. Another way we can see the volume being constructed. And anytime you have a similar figure, if you take whatever figure it is, trapezoid, hexagon, if you take that area times your H, then that gives you the volume. Well, over here, I'm starting with a circle. What's the area of a circle? The area of a circle is pi r squared. So the volume is going to be pi r squared H, isn't it? And that turns out to be it for the cylinder. Pi r squared times H. Take the area circle formula, circle area formula, times your height. Okay? All right. So that's volume. A little bit of explanation behind it, but okay. Let's talk surface area for the cylinder. Surface area for cylinder? Well, two of the surfaces are easy enough. Two of the surfaces are what? Well, the top and the bottom are circles. Area of a circle, pi r squared. So I've got a pi r squared here. Then on the bottom I got a pi r squared. I've got 2 pi r squareds, don't I? That leaves then the rest of the can, the body of the can, the cylinder, the middle part of the cylinder. Well, here's what I'm going to do. Let's say I take that cylinder and cut it down the side here and then lay it out flat, roll it out flat. What shape would that roll out to be? Well, if I roll this out like this, wouldn't I come up with a nice rectangular shape there? Yeah, I come up with a rectangle in shape. Okay? Now, to get the area that I need its length and width. Well, this way, obviously, you got your height. So that'd be h. So I've got my width. Now this let's think about the length then. Well, if you think about the length, that corresponds to, over on the can side here, that would be this part around here, wouldn't it? All the way around this circle. What is that called? Isn't that the circumference? So this side right here is the circumference of the circle that I started with over there. Now, what is the circumference of a circle? There's a formula for that, right? Circumference of a circle is 2 pi r. So this, laid out flat, the length would be 2 pi r. Well, if that's 2 pi r and that's h, then the area of this is 2 pi r times h. So that completes our surface area formula for a cylinder. 2 pi r h. Okay? All right. Well, from the cylinder, a good place to go here is to our cone. There's a little bit of a relationship, at least with one of the formulas. Okay, so a cone, yeah, we've got, comes to a point there, and then the base is a circle. So just like the cylinder, you need two things. You need to know the radius of the circle, and you need to know the height, top to bottom. How tall is your cone? You need to know those two things. All right, well, volume. Turns out the volume of a cone is related to the cylinder. What I like to ask as we're going through here is this. If I were to take, let's say I took a smaller cone here, let's say it's where I can fill it with water. It's empty, like an ice cream cone or something like that, but I can pour water into it, okay? So I've got whatever radius, whatever height. If I took a cylinder with the same radius and the same height over here and thought about how many times would I have to take the cone, fill it with water, and pour it up into the cylinder. How many of those cones would it take to fill the cylinder up? Well, most people would say 2. Most people would guess 2. However, it takes actually 3. 3 of these cones, I would have to do 3 of those cones filled with water, poured into that, to fill this cylinder up. Same dimensions on it. So, having said that then, since the cylinder's volume is this, and it takes 3 of those cones to fill it, wouldn't the volume be a third here? A third times pi r squared h is the volume of a cone. Yeah, it's pi r squared h, like the cylinder, but times a third. That would give you the volume of a cone. Now, on the surface area. For the surface area, Well, one of them is easy to explain. One of the surfaces, I've got a bottom surface that's a circle, so that's a pi r squared, isn't it? Area of the circle is pi r squared. So that surface is that. Well, that leaves then the rest of the cone, the top of the cone. You can lay it out flat and measure it and all that, but here's what it turns out to be. It's pi r times the square root of r squared plus h squared. That's a nice little one, isn't it? A nice looking little formula, which brings up in my mind here to point out that the volumes and surface area formulas I do provide on a sheet, so you don't have to necessarily memorize the volume and surface areas we're doing right here. You just have to be able to use those formulas and plug in the various numbers. All right, so let's do that. Since this one's a little different, longer. Let's do a cone. Calculate volume and surface area of it. All right, so let's say we do have a cone. And the cone has radius. Let's make it radius. Let's make it 8 centimeters radius. And then the height, we'll say the height is 12 centimeters. Okay? So what's the volume? What's the surface area of that cone? Volume is 1/3 pi r squared h, so that would be 1/3. Pi, of course, we can use 3.14. Radius is 8, so it would be r squared. So we square 8. Height is 12, and then multiply that by 12. So we can figure all that out. 1/3 times 3.14. 8 squared is 64. Multiply that by 12. All those together should get it. All right. So 1/3 times 3.14 times 64 times 12. 803.84. Okay? And the units, well, the units for volume, always cubic units, so centimeters cubed. Be the volume. Now for my surface area. Well, the surface area, I'm going to plug in the same things. R is 8 and H is 12. Okay, so that's pi times 8 squared plus pi times 8 times the square root of r squared would be 8 squared and h squared would be 12 squared. Okay, here's how you do this. Well, all right, so that would be 3.14 times 64. This would be 3.14 times 8 times the square root of 64 plus 144. 64, 8 squared, 12 squared, 144. Okay? All right. Well, let's see. 3.14 times 64. I got 200.96. 3.14 times 8, 25.44. And then 64 plus 144, do you want to add those? That is 208. 208. Okay. One thing we should point out here is the next step in the order of operations. We've got plus, we've got times. Times comes before, so order of operations wise, I'm going to multiply 25.44 times the square root of 208. First of all, let's see, the square root of 208, that's along about 14.42. So I'm going to multiply 25.44 times 14.42. First of all, that's 366.84. Then I add 200.96. Then I add those two together. Okay? So be careful with that. Get your order of operations right.